7.4 is about properties of logarithms. Like everything in math, everything has properties. What's kind of nice about logarithms, it follows the same type of properties that like exponents have. So like when you multiply like bases, you add your exponents. So addition and multiplication are paired, just like in exponents. Okay, quotient property, when you divide, it ends up becoming subtraction. So subtraction and division are paired. And then power property, so to a power ends up becoming multiplication. That n comes out in front and becomes multiplication. So when we're trying to make this a single logarithm, we just talked about subtraction pairs with division. Well, we have two logs, I'll make it one. So let's make it one log. Base stays the same. It just becomes division. 32 minus 2 becomes 32 divided by 2. That's how you get rid of the one log, based on the quotient property, which is up here. Okay, which gives me the log base 4 of 16. Now, let's simplify this further. What's kind of nice is because our base is 4, I want to take 16 down to 4, just so the base and the number match. So log base 4 of 4 squared, that's how I get 16. Well, again, based on this property here, the power property, that actually comes in front. So 2 log of 4 base 4, and that just ends up canceling. So our final answer is 2. Log of 4 base 4 is just 1. Okay? Now, what about b? Well, again, we have this up top. Multiplication becomes a power. Multiplication becomes a power. So you really have log of x to the 6th base 2 plus log of y base 2 to the 5. Sorry for that interruption from Siri, apologize. But plus, I'm sorry, Alexa. But when you add, it becomes multiplication. So you end up with log of x to the 6th, y to the 5th, base 2. Now, example 2, you're going the opposite way. There you had it expanded and you're condensing it. Here you're going to go from condensed form to expansion. And again, we're going to use the same thing. We know that division pairs with subtraction. So we can break this up again. This doesn't have any base, so we're just going to assume it's base 10 because the base is missing. So division pairs with the subtraction, like I just said. Log of 4x minus the log of y. Well, this is where you'll get stuck. There's still this to deal with. Understand that's still not totally expanded because what operation is going on there? It should have a single monetary or single number in that position. Okay? So I need to take a look at this, and that operation is multiplication. Multiplication pairs with addition. So if I want to expand 4 times x, I'm going to make the log of 4, again, pairs with addition, plus the log of x minus the log of y. And there's your total expansion. Now, you can go ahead and work with 4 if you wanted to at the start there, but you don't really need to because the base is 10 and 4 is not going to be able to do anything with that base. So let's take a look at b. Log of x to the 4th divided by 729 base 9. Again, division and subtraction are paired. So let's break it up. Log of x to the 4th base 9 minus the log of 729 base 9. Okay, we'll deal with that in a second, but let's come over to here. This is still not good. I still have to do something here. What can I do? The whole purpose to logarithms is to get that exponent down in front. Just like we talked about with trying to solve, that's what we're doing. That becomes 4 log of x base 9 minus the log. Well, let's break 729 down a little bit. Okay, what is 729? We've got base 9. So chances are we want to break that into 9 to something. Well, you can mess around with it. You can see what happens. But 729 breaks down into 9 cubed. Okay, what happens to that 3? Comes out in front. So you end up with 4, the log of x base 9, minus 3 log of 9 base 9. Well, again, log of 9 base 9, that's just 1, so it cancels out. So our final answer is 4 log of x base 9. Minus 3. Example 3 is about solving, and we talked about this. This is what we're always working towards. The expansion, contraction, and condensing and expansion is all part of the solving process, and we'll get to that and when you use that. But again, this is kind of our base solve here. You're going to use this change of base formula. So the log of m base b really just becomes the log of m divided by the log of b. They use that c not equaling to 1, but because of our calculator and technology, we're just going to use log, and that assume base 10 so we can use our calculator. So you end up with the log of 27 divided by the log of 81. And then simply calculate it from there. Log of 27 divided by log of 81, it will give you 0.75, but again, when you hit fraction, it'll give you 3/4. So same thing here, log of 36 base 5, your change of base formula ends up becoming the log of 36 divided by the log of 5, and that will allow me to get a value when we're dealing with this stuff. Okay, and that's going to give you about 2.23 when you plug it in the calculator.